we'll get started right away because we've got another jam-packed schedule of talks, and I know that most of you are out working on your hackathon projects in the time in between. I'm Andrew Miller from UIUC. I'm one of the co-directors of IC3, and so I will be the host for the morning of today's events anyway. We'll get right started with our first session of this day. I'm really excited to be able to introduce this very excellent panel who will be talking on the topic of multi-party computation in practice and what's on the cutting edge of it and how to participate, stuff like that. So this will be informal. I think we're in gallery view, so this looks all right. Everyone who's not in the panel, if you're joining and just hearing this, please make sure to turn your video off. Our panelists, I'll let you go and introduce yourselves in a little bit more detail after that with the first question, but we have Avishai Yanai from VMware Research. We have Marcella Hastings, who graduated from University of Pennsylvania pretty recently and is at Bolt Labs right now, and Omer Shlomovitz from Zengo. All three of whom have some different perspectives and different roles, but all participate in research and development on multi-party computation. So what I would like to do by way of a first question is turn it to each of you in order you could introduce yourself and maybe just say what kinds of things related to MPC you're working on, what you think is interesting or what you're excited about right now. So Avishai, why don't you go first?
Sure. Thank you, Andrew. Thank you for inviting me to this panel. So as Andrew said, I'm currently a researcher in VMware Research. I'm based in Israel, and we are trying to solve many sort of things related to MPC, and like both trying to solve and to find new directions, new applications to MPC. It's not very easy. Currently, a grant project that we are working on is related to CBDC, central bank digital currencies, and there are many other projects that tries to bring new ideas, new approaches to solve this to solve this problem. One thing that we took from the beginning is the fact that we have to solve that problem while taking care of both the privacy of the users and the ability of governments or authorities to audit the system and for example, check that there is no anti-money laundering and anti-terror transactions. And this is where the challenge is. And while there are many solutions from the 90s or even the 80s on anonymous transactions, such efficient ones are not there yet. So this is one of the main projects that I'm collaborating on. And besides that, I'm doing other types of MPC protocols like private set intersection, which I've been working on a lot, and general MPC and anonymity. I'll be giving a talk today later on about Blinder and what we can do with it. So yeah, I'll be happy to expand it more.
Okay, excellent. Marcella, would you go next?
Sure. Yeah, so my name is Marcella Hastings. I recently finished my PhD this year at the University of Pennsylvania, where I studied secure computation in practice. So my research there focused a lot on looking at software implementations of MPC engines, looking at what their capabilities were, and looking at why, like how they're used and what barriers remain to making MPC more practical. Now I'm at Bolt Labs, which is a small company working on privacy in the blockchain space. So we work on solutions for private layer 2 payments. And my role there is mostly, or I guess it's a mix of working on our protocols to design protocols that can do this, and also building cryptography software in Rust focusing on, I've been doing a lot of zero knowledge work recently, but next up is an MPC engine.
Okay, so zero knowledge. When you say working on zero knowledge and next up is MPC, are you looking at like the combination of both of those, like protocols involving some combination of both, or for fairly separate tasks?
They're pretty independent. So we basically have two approaches to our overall protocol for layer 2 privacy, and like the hard part of this problem is that you need to get a signature on a transaction or like an authorization on a transaction without seeing what you're signing. So in some specific use cases, you can use blind signatures to do this, which means you need to like provide a zero knowledge proof that you've constructed a transaction correctly and then sign it in zero knowledge. But if you're working on a cryptocurrency that doesn't accept signatures that use a special purpose blind signature scheme, the general purpose solution uses MPC, where you can just encode an arbitrary signature scheme and sign it under MPC.
Okay, got it. All right, and Omer, how about for you now?
Yes, hi, and thank you for inviting me. I'm also, my name is Omer, I'm also based in Israel. Just like Avishai, as a matter of fact, we shared a room for a couple of years at Yehuda Lindel lab at Bar-Ilan University. And currently I'm running research at a small startup called ZenGo. So it's a startup that is doing, building a wallet for consumers. And we are handling a lot of the questions around key management, like we do key management using MPC. And this was kind of our segue into research. Our work is open source and mostly focused on threshold crypto. So my group is, let's say, 50% focused on doing more theoretical research and 50% on more applied or implementation of MPC and related cryptography. And I think that like I would want to give you, ask about what excites us and like current focus. I want to give 3 examples of research that is now ongoing and that literally like, I don't know, for me at least, it's super exciting, blows my mind every time I think about it. So first is a project we call Threshold Lightning, and we basically try to impose our model, our security model, same as we do with Bitcoin and other chains, L1 chains, on the Lightning Network or Layer 2s, meaning that like decentralized key management, and we keep hitting or bumping into walls. So each time we bump into a wall, we try to find clever ways to bypass it. And we finally hit a very interesting wall, which I believe that solving for it, which is now a joint work with another company and some other researchers. So it's Fireblock, SAS, and some other companies. And I think that solving this latest block would be the last one, would eventually lead to us having threshold lightning, as we call it, and would also be used for many other applications. And so this is maybe one example. The other thing is threshold ECDSA. So ECDSA is the signing scheme used in Bitcoin today, and therefore in many other chains as well. And I mean, at least for me, it was very nice to see the involvement of protocols for threshold ECDSA, and we kind of try to help and make progress through this very interesting subfield. And right now we are focusing on a research which for me would be like the next generation of threshold ECDSA. So it would introduce new assumptions that are very, very interesting, and I hope would allow for other cryptographic constructions to be built on these assumptions, and it would also provide huge benefits to, like, for example, completely non-interactive threshold ECDSA. And finally, and the third example is, I have the time to think because you asked me the last one, so I had the time to actually process and give examples. So anyway, the last one is a project about random beacons. So random beacons are not a new concept, and there are a few already in the wild, but this project is going to make them, I hope would make them very much practical and like available for, I don't know, the gaming industry and so on. So we're kind of building this hierarchy of random beacons with different security assumptions and efficiency trade-offs, of course, based on threshold cryptography. Yeah.
Okay, awesome. Yeah, I appreciate that you got time to fill up examples when going last in that sequence. I'll give some answer to this for myself, or I'll just mention two things that I've been really interested in working on. And the kind of theme that I'm most interested in is kind of closing the gap between these nice frameworks like smart contract programming that developers in the cryptocurrency world get really excited to use and build upon, and what you can do with MPC frameworks that are available, like MP speeds, among others. And my grad student Yunchi, who I've been working on this topic with, gave a talk yesterday about our Ratel project. Sylvain and several others helped too. That's about trying to integrate the smart contract programming environment with a generic MPC framework so that you can build some smart contract applications that use MPC. And really one of the big challenges that we've seen, and then our approach to this is to basically accept that MPC generally implies a bunch of computation overhead compared to the no privacy baseline, especially if that's your baseline for comparison. And so for us, something that we try to do is look for applications that are a really nice fit, meaning that there's some kind of way you can hide or mask the latency of a slow MPC operation, either by like using the automated market maker rather than a full order book leads to a much simpler operation where the latency isn't so bad, or processing things in batches for settlement transactions where maybe the latency requirements aren't quite so high. And one other thing that excites me is this idea of publicly auditable MPC, basically adding zero knowledge proofs to your MPC so that you get a kind of backup guarantee. Of course, MPC doesn't give you security guarantees if all of your nodes fail, or depending if you use honest majority or dishonest majority, maybe if even a third or more of your nodes fail, then it might compromise your MPC guarantees. But through the use of publicly auditable MPC, which is basically combining zero knowledge proofs with MPC, you can get a backup guarantee that there's at least the computation was carried out correctly, even if the availability and privacy have been lost. So we have a paper up on arXiv, and we'll be at the Security and Privacy on the Blockchain workshop at EuroSP pretty soon. And the lead author of that is Sanket Kanjolkar, who graduated from Illinois a little while ago and is now at Blockstream.
Actually, just read this paper over the weekend.
Yeah.
Extremely interesting. I can recommend it. It's also well written, like really structured well. So it's educational on top of everything.
Oh, if only Sanket were here, he would definitely, I'll be sure to read it.
I talked with him, yeah. Actually,
okay,
we spoke
excellent.
this week, yeah.
Yeah, so, I imagine that I guess what I wanted to do for the focus of this discussion really is, I know that I hope that this discussion is going to be useful to all of the students who are in here. I bet there's a lot of people who are MPC curious or have through the hackathon environment or in a primed learning new tools kind of mode. So they might be receptive to being pointed at challenges or ways of getting involved in MPC. So the next question I would want to throw around to you all, maybe we'll go in order again, but you can also shout out if as it strikes you. But what would you say are the best challenges for MPC? Not necessarily the hardest problems to solve that need the groundbreaking research, but the challenges that you think would be good to for newcomers to this world to get started on. I think that it's kind of a different circumstance now. All of you mentioned something about, I think every one of you has like a foot in the research side or theory side and in the development and practice side. And so, I mean, I think as things shift towards practice, the barrier to entry in MPC for new students wanting to do research project, I think gets lowered as well. So maybe I'll call on you in the same order if no one's shouting out. Avishai, do you have any reaction to that?
Sure. First, I think that newcomers, this is not something that I did when I started reading and working in the field of MPC, but I recommend others to do that. Usually when we start and read papers, we after the first paper that we read, we usually have ideas on how to improve it. Usually those ideas are bad. I mean, it's good that we have ideas, but like when we just started to know a field, we don't have any context, and and probably our ideas are lacking. Maybe other people thought about those ideas, or even they're just bad because we don't know the context of what metrics are important. For example, let's say I want to improve communication, but actually the computation is the bottleneck in that kind of in solutions for that kind of problems. So what I recommend to newcomers is first, if you investigate some problem, then first read. I don't know, I can't just throw a number, but at least be confident that you know the context, and you know several solutions to the same problem. That will give like you could compare solutions and know like the metrics, the important metrics better. Of course, MPC, like papers on MPC are not easy ones to read, and fortunately today we have a lot. Okay, I don't know if a lot, but we have several very good groups of chats or like study groups that help even newcomers to get into papers. And one such group is led by Omer in Zengo Telegram channel. So I recommend people to ask questions, and a lot of questions, and there are a lot of people that will try to help you. I see that one writes in the chat that the BIU winter schools are very helpful, and I agree with that. And yeah, I remember there were also even study groups that watch together videos from the BIU winter schools. Yeah, that's my recommendations for newcomers.
What's the name of that Telegram group? I know that I'm on it, but I don't even know how to get the name of the Telegram group. Is this something that someone would be able to search for easily? Takes open membership.
Zengo X, Omer?
Yeah, I'll share a link, sure.
Okay, awesome. And yeah, I would definitely also recommend those BIU winter school recordings. They're really great. You have to watch a bunch of them, and kind of it takes quite a while to soak in. That study group idea I thought was pretty helpful. Something you said resonated a bit with me too as well. I think you said that you would recommend reading a lot to get a very broad view of all of the solutions that might take part on something, rather than jumping at the first paper you read when you think, oh, I can do it better. At the same time, whenever I've experienced like thinking that I could do something better, I spot what I don't like in someone's paper, then that kind of motivation, even though it usually turns out to be completely wrong and there's a good way they did it that way, that feeling of, oh, I see the way I should do this better. I've usually found that to be my best source of motivation to carry on with something. So maybe both of those kind of fit together in the advice. Yeah, so Marcella, I wanted to ask you what kind of your suggestion would be to folks starting. I know that your systemization paper on MPC front ends was super valuable for me. So I think you have a very broad perspective of not just a snapshot, but even like the evolution in time of MPC front ends and the kind of developer tools available.
Yeah, that my plan is to just shamelessly self-promote for this question. So yeah, MPC is a pretty big topic in general. If you just sort of pick one MPC paper, as was noted, you'll probably be very confused very quickly. So I did write a paper about, if you're interested in applications and software and want to understand some of the technical difficulties that come with implementing MPC and using it, I would recommend my paper, which is a systemization of knowledge of MPC software frameworks. And we started out with a bit of an overview of like the basic building blocks of MPC and talk about, some of the main challenges in execution. So that will give you some direction for like what cryptographic basics do you need to understand in order to understand why MPC is the way it is. Oh, thanks for all the links. And then from there, I also have an open source repository. So if you want to try using some of those frameworks, like you're welcome to go play around with them, like try implementing some examples, see what's slow or fast, and like get a better sense for whether MPC is a tool that you could use in whatever application you might have. And you know, those things also have a lot of citations, so you can use that as a jumping off point to finding more specific areas that you're interested, or diving into a specific project if you want to know more.
I think that there's
MPC
been
is a big area though. Sorry,
Okay, I'm not sure if I was cutting you off at the end. Go ahead.
I got into MPC by writing that survey paper, and it was like very all in. So if you want to know my exact like that is an introduction to MPC from at a very personal level.
Okay, that's awesome. That's also, I think, pretty general good advice. A good way to get started as a new grad student is to write a survey on the topic you want to break into. It's something you do to learn, not because you're already an expert, but as a great excuse to become an expert. So I think that experience probably is good advice people might benefit from. Have you seen, like, when I try to imagine pointing someone at an MPC toolkit, especially if it's a student, I try to imagine giving them like a challenge project to get going on. And I guess a question to you is, have you seen a shift in like what are the good development examples? Like classically in MPC, it would be answering these questions that to me were kind of like the socialist millionaires game, like who's richer. It's just not quite connected to something useful. So I found it less compelling as, a starter example from, old MPC papers. All three of you have mentioned, projects that are related to finance in some way. I kind of think the cryptocurrency or blockchain finance themed applications are already more compelling because it's a little more, I don't know, natural where the security angle fits in. So, do you have a thought on basically like the shift in kind of recommended examples at the time, or even more specifically, like what would you point a newcomer to, make as a first, say, 4-week project, if that's how long they had?
Mm-hmm. Yeah, that's a good question. I think from what I've seen, I feel that like the examples that people implement have not necessarily changed. Like, yeah, there's the millionaires problem, like basic comparisons. There's a lot of inner products out there, partly because I think those can be made really efficient. So like, it's a good thing to show off if you're writing a paper. And that lends itself well to if you're trying to do some kind of TensorFlow application or like a machine learning thing, but it also doesn't scale that well in terms of what you can do non-privately. So like, I'm open to hearing what other people have to say if there are better and more interesting examples.
I would actually choose a project that does not involve multi-party, but actually, for example, private information retrieval with a single server. Although it's not the most efficient way to solve that problem, but it will put a lot of insight to whoever implements this. Private information retrieval actually gives a user a way to access a database without the database owner being able to know where the user is accessing. And there are many solutions. The most efficient ones are based on several servers. But if you want to take a single, I think that a single server solution would be easier to implement, especially if you mentioned 1 week. I think that things that involve communication of multi-party and a lot of synchronizations are harder to implement.
Interesting. That's a cool suggestion. I don't think I haven't heard that kind of posed that way, as that's a nice idea for a starter project. I could almost imagine someone doing like an IPFS backend using PIR rather than something transparent. I think it's a cool suggestion. Omer, do you have a reaction to this? You've had more time to think of 3 examples of starter projects or suggestions for newcomers to get started in MPC.
Yeah, so I mean, connecting directly to this follow-up question, I do believe in the classical examples, right? So MPC is a technology, and it's a beautiful technology. And this is like something that I think what captured the imagination is this in this classical example. This is like part of the beauty of them. Like it's something that you do, you can understand it relatively easily, and you can also build it yourself. I mean, I'm right now, by the way, and it also maybe will provide you a hint about where the industry is going, or the way that they observe MPC. So I'm writing a book or a booklet or something called a live project that is focused, like Avishai said, not on the multi-party case, but on the two-party case in this case. And I'm taking I have some examples project there of private set intersection, or like the simple ones, Yao millionaire problem, and what else I have there? Private matching, like you want this matchmaking program that provide you with some kind of privacy guarantees. And I think these are like, by the way, if anyone wants early access to it, so please ping me with your GitHub handle, because this is kind of still in the works. But I find them like really fun to do. Like it's really in the scope of like a couple of weeks, few hours, maybe a week to work on, and like you have something, you accomplished something. And I mean, you know what, maybe taking one step back and relating more to your first question, like, and then like, you know, MPC is a technology, as I said, but we need to, it means that we can unpack it. What does it mean? Like any other technology, there is this building blocks. So at least in MPC, there's the math, and there's the cryptographic primitives, you know, the zero knowledge, the commitment schemes, the encryption. Then there's the protocol, the protocols, distribute key generation. How can I choose between different protocols, which one fits me the best, the adversary model, and I mean, and such. And then you have the communication, which is, you know, like distributed computing. So I think that like a good place to start is by maybe looking at any one of these pillars or layers in the MPC, let's call it the implementation stack of MPC. You can start from the math and then like ask yourself, what is the foundation? What are the assumptions in the mathematical assumptions? Can we challenge them? Can we change them? I mean, we have a work on replacing elliptic curves with class groups and see how it behaves. I mean, this is like just one example. You can also focus on the primitives, and this is where, for example, you can plug in zero knowledge. What happens if I take one zero knowledge proof and replace it with another one? Some protocols are built in this modular way that you can actually take parts and put some other parts and see what it gives you, like maybe some better parameters or better model or more optimized efficiency in some aspect. Then there's the protocol. I mean, many of the cryptography, many of the researchers in academia are focusing on the protocol layer and like building these innovative protocols. And again, this is like really beautiful to see, and there's amazing tricks there. So just by reading many papers, you can get yourself accustomed to the security that are usually assumed in MPC, and the models and protocols and how they can be connected to one another and plugged into one another, and then you can create something new with this Lego, or just make, I don't know, make some changes. And then the communication, right? So I mean, for us, for example, we had a project on the communication, which we said maybe we can have something, let's just take apart the communication, let's put some state machine replication instead, or maybe do something which is more proprietary to MPC protocols and see if it would help us to scale. Or another project was to use the signal application as the communication layer for MPC. And now we have, like, you can run any MPC you want on your mobile using your signal app. So I think this is like my view on this topic.
That's awesome. I like that kind of suggestion of, imagine splitting apart the MPC development stack into layers, and then that gives you a suggestion where to dig in for projects of switching things around. I guess I had two other ideas for questions, and then maybe I'll kind of go ad hoc after there, do audience questions after there. I think what I wanted to ask next was about, could you do some comparison basically of MPC versus some other kind of, relevant technology that's there? Like, to me, I usually think about MPC, the progress of MPC reaching compared to snarks and zero knowledge proofs. So like you've seen in the cryptocurrency world, tons of people like get the idea of snarks, whether it's from Vitalik's blog posts or just from the development and release of things using zero knowledge proofs like Zcash or any of the ring signatures and range proof sorts of things. I mean, in a very broad spectrum, I would imagine that it's roughly like zero knowledge proofs are the furthest towards ubiquity, everyone being at least a little bit aware of them, if not right set, ready to go program a zero knowledge proof. And then on the extreme end is fully homomorphic encryption, which is, there's some toolkits available, but it's still, you know, implausibly slow for most tasks that I can think of. And I kind of peg MPC right in the middle. But that's kind of just a stylized view. I wonder if any of you have any other like insights that kind of stem from a comparison in technology spectrums or timelines where MPC fits in. Maybe I'll just ask if any of you want to react to that. And if no one does, then we could move on to a different question.
Yeah, I actually was thinking about that one. I've been working in zero knowledge a bit, as I mentioned, but I still, theoretically speaking, I know a lot more about MPC than I do about zero knowledge. So I may be totally wrong on this, but my impression is that there are sort of two axes here. One is like technical abilities, like is the cryptography mature? Are the software libraries well built out? Is there a lot of like, can you use it in practice? Are the threat models well defined? That kind of thing. And then on the other end, there's sort of the social adoption. I think zero knowledge proofs have gone very far in the social direction for sure. Like people in cryptocurrency know what they are, people can talk about them. They're easier to reason about in some ways than MPC is. And so I think it has a lot of social development, but from what I've seen, the libraries are not, the open source libraries that I've seen are not fully developed. Like there's still a lot of work to be done, especially in terms of like compiling an arbitrary application into a circuit representation that a zero knowledge engine can consume, and that kind of thing. So my impression is that MPC has a lot more actually software development. And there are a lot of researchers doing a lot of work on both like the circuit compiler portion and the MPC execution portion, but it has a longer way to go in terms of social adoption, like finding applications that academics didn't make up that like came out of real use cases, and convincing various stakeholders that it's not magic and that they're really secure and you don't have to sign an NDA and your data's not going anywhere.
You see a lot of overlap in the software tools. That's a really interesting perspective to say that MPC may even be further ahead in terms of the tool available quality than zero knowledge proofs. I mean, when you get down to a very low level, there's some significant differences between them, but one step zoomed out, okay, these are both about compiling to arithmetic circuits or Boolean circuits or some form rather than just, you know, register-based assembly code. So, I mean, if you get experience with one, does it likely port over to working on the other?
I'm not sure actually. So I was at a workshop earlier this year that was trying to talk about this problem, and I think they have, like when it comes down to it, they have, the requirements are just different enough that you can't like take an MPC circuit and stuff it into a zero knowledge execution. Like I think like zero knowledge optimizes for slightly different things. I don't want to go into too much detail because I'll probably say something incorrect, but in my experience, they're just different enough that you can't flip-flop.
Okay, perfect high level point. Omer, Avishai, any reaction to that?
Maybe I can follow on what Marcela said and propose a reason to why zero knowledge proofs are much higher in the social side. And in my perspective, I think that it is much easier to maybe penetrate a market or propose a solution which does not requires the collaboration of multiple entities, which usually requires a lot of regulations within like inter company policies and a lot of legal stuff. So zero knowledge usually does not require that. And in fact, there are so many deployments of MPC, and I think this is the reason. Although MPC is as you say, the theory and even tools that exist are more advanced and even sometimes more accessible. So that's what I think.
So you're saying that the like the almost the institutional or organizational difficulty in getting multiple stakeholders to run nodes is one of the big obstacles to the deployment.
It's not only the it's not only the technical challenge, but it's also the legal and bureaucratic challenge, and like to have several entities to collaborate over MPC. They have to know what they get out of it. Like what is it should be profitable for them. Like companies don't move. They don't make a move just because something is cool. I mean, they're looking for the application and what what they can get out of it.
And it sounds like that's not fundamentally different than like permissioned blockchains, even like consortium consensus protocols, even with no MPC layer. That adds another technical challenge to it. But still, you know, how are you going to get multiple different businesses to be motivated and invested enough to you know, run some different node of consensus software? Is that kind of a similar problem then, or do you envision any you know, way around
I think this is exactly the same. Yeah, the same challenges appear in permission blockchains.
You think there's an opportunity around here to improve? Like maybe that's a social bottleneck worth overcoming somehow.
So about MPC, I think there is a market education phase that everyone is going through right now, because the market didn't know about MPC few years ago, and now it's penetrating, but very slowly, and people are slowly getting to know what they can do with it, and potentially they will come up with the next killer app which require MPC. But I don't know if we can do much about it to accelerate it, and it takes time.
Omer, any thoughts on the positioning of MPC in the timeline of technologies?
So first, I want to agree that snarks and MPC like they are different. I mean, the canonical example is if you want to compute an inverse with MPC, it's hard, and if you want to do it with snark with like a constraint, it's really easy to express it. So circuits are not compatible, like optimizations are different. So this is one thing, but I think more to the point, I do want to make an argument that MPC has penetrated many industries so far, and is only going to increase. So I'm just gonna, I mean, this is my point of view as being part of the MPC Alliance, which is a consortium of companies. Marcela is also part there, but in my role in the MPC Alliance, I get to actually interview many companies that are like any company that will join us, and we have around 50 of those on like different size and shape and industries. And I can say for a fact that there is a huge demand for MPC researchers throughout several industries. Obviously, in the blockchain space, this found like one killer application in around key management, and also around privacy and privacy preserving machine learning. This is probably another interesting application. Also the big companies, I mean, Facebook, Google, they're all very much into MPC. We know for a fact, again, that they're going to deploy solutions based on MPC for privacy, for their for EdTech, to keep, anyway, for privacy matters. So at least from my point of view, MPC has penetrated really nicely, and there is huge demand for it from like the technology and the know-how of the technology.
Do you imagine that the is the MPC aligned? Like, are you going to run a 50 node wide MPC instance then? If,
yeah, we
is
actually
that one of the
discussed
things?
it.
Yeah.
Yeah, so yeah, I mean, we discussed it. It was brought to the table several times already. There's a bunch of, I mean, not all the company. It's not easy for any company to just say, let's run a node and start computation. But the high-level goal was, let's provide this social good of like 50 nodes of running any MPC computation that like people would want to, and would be able to facilitate it. And you can know for sure that, for example, I don't know, Alibaba would not collude with Zengo, or like that those are like public companies or companies that are public facing, and like the trust model here is maybe can be more relaxed in a sense.
What I had next to talk about, and then I'll be out of questions that I think I have in mind, and then switch to something else, either ad hoc or audience questions. But we've already been talking about a bunch of blockchain related applicability, and I know that all three of you are doing things connected to involving both blockchains and MPC. Do you have any observations or insights you could offer on either what are the most important say blockchain industry needs that can be met with MPC? I think each of you in your intro described kind of which kind of part of blockchain challenges you're tackling with MPC. So you could even just expand on those. And if you're satisfied with the expounding level that you did in your intro, then maybe you could interpret the question as what do you see on the horizon as problems that blockchains face that might be addressed through MPC? So I will let you react amongst yourselves to see who goes first.
I would say that I'm very excited about Avishai presentation follow-up today about how to combat MEV using MPC, for example. Like, I think it's a very promising direction. There's also this threshold decryption scheme that is being cooked that also is around the same topic. So I'm really excited about this front.
Yeah, I'm excited for that too. I don't know how we're going to pass the time until then. Anything to add to that? I don't want to just say jump into your talk right now, but you're welcome to build on that, Avishai, if you want to.
Yeah, it is something that I will expand later in my talk. But one question that like arise, or one difficulty that arises when trying to deploy a system, like a system that was developed first theoretically, and maybe we had only a prototype of it instead of an actual system that works in the real world. So when we try to deploy it, we face several problems. So specifically in Blinder, which is a system for anonymous broadcasting, it's called the anonymous committed broadcast. The problem that we faced is that in theory, the system works because we assume that network is synchronous. But in real implementation, when we want to actually give a service to users, we cannot assume that, because sometimes if a user does, for example, Shamir secret sharing, it has to give different share to different server, and in our case, when we split the time access into several intervals, and in each interval we serve a batch of clients, we cannot guarantee that all servers will have their shares until the end of the interval, until the end of the batch, right? So we have to decide what to do with those shares that have not been arrived. And this is a real world question that we faced only when actually tackling a blockchain related problem like that of MEV. Before that, we had a nice prototype that works in a synchronous network, and everything was nice. But actually, now that we're trying to make it real and serve people, we face this problem. And yeah, I think that the combination of MPC solutions with maybe it's not only with blockchain, but actually with the real world, make us think more on usability and how things will actually work.
Marcella, do you have any kind of insights based on where MPC fits into blockchains? I know that I think what you're working on is like kind of layer 2 connections with MPC specifically. Do you think that that's going to kind of continue to be the hot layer of the blockchain stack where MPC fits in?
I mean, I think layer 2 makes a lot of sense for MPC because it allows you to shrink the number of parties that are involved. Like at layer 1, you know, you can't involve every miner in every MPC computation because like MPC isn't ready for that yet. But at layer 2, you're able to sort of shrink the application space, shrink the number of parties involved. And that means you can build something a lot more efficient that is actually competitive to like non-private solutions. And in our case, you know, it lets you make private computations or make private payments on any blockchain, including ones that aren't inherently private. So it's a place where you can add additional security properties to things that were not built secure by default. So, I mean, yeah, I think my company is doing cool stuff. I think the other place that is a good application that also falls under this sort of limited scope thing is private key management. Like even outside of how any specific cryptocurrency works, dealing with your private keys is such a hard problem, and people lose them all the time and screw them up or have them get stolen. So like the work that Unbound is doing, and I think several other companies are doing in the private key management space, I think is a really good MPC application.
I guess Zengo counts as among those as well. Yeah, I think it's really neat how MPC has like stepped up to solve this very specific problem of retrofitting like key management solutions into systems that already have their key format and can't change it. So they're blockchains and they're running and weren't designed with this. And so the MPC is kind of showing its flexibility by being able to be applied, retrofitted to give some security to those. I think that's a pretty cool insight.
If I may add on this, just that, I mean, maybe to correct somewhat, I don't see it as a full solution. I mean, MPC is part of a system, and it's true that like you can take existing cryptography and replace it with some MPC protocol, but it would introduce to you maybe some other problems, like the classical trade-off is with how you do recovery now that you have many shares. But the system itself, the MPC system, as I described before, also in layers, like you now replace your private key with this more complex crypto system, and all of a sudden you need to reason with the math, the more cryptographic primitives, zero knowledge proofs, communication, like you need interaction. So it also creates more problems and also more opportunities. And definitely like one important part of a system, but not the full system.
Do you think that then other, what's the question that I have out of this? Is it like clear what other components kind of fit together next to MPC to make a full system, or is like more of like an open question, like we need as of yet unfathomed technologies to kind of fill the missing parts besides the MPC?
I think it's a little of both, right? So to give examples, one thing, like I said, recovery is an important problem that goes hand in hand with MPC. Like once you introduce, like instead of one party, you have 10 parties. So now you need to find a good solution how to do backups to each one of the 10 parties, or like you need to have a threshold, and then you need to learn how to handle this threshold in all sorts of different use cases of, I don't know, theft and lost keys. But on the other hand, it also still open, meaning that like when you imagine key management, we imagine it, let's say, used for signing on a transaction. But what if my key management is a solution for decentralized ID? What if I don't know, like BitCloud is a decentralized social platform? Like how do I do decentralized key management for for something like this. So I think there is still like it's an open question about the components that goes and what exactly does it mean. And also the connections between all of these problems, like when I want to do it one for blockchain transactions and also for decentralized ID, how is it connected?
Either of you want to jump in and react to that? That was at least like a potentially more open-ended thing about like what else is missing besides the MPC component in a whole system.
I actually want to to follow several things that we were touching upon earlier in this conversation. One of them is something that is missing within MPC systems right now, or actually not systems, but maybe tools for developers and researchers. And it relates to the work of Marcela. Basically, there are a lot of platforms that allow us to compile our high-level code into circuits and then run them. But I think we are missing the last mile, and this is especially for beginners. This is also relates to the how beginners. What's the best way to beginners? And I think this is something that is missing for beginners. For example, and it's not even it's not only for beginners. It's even for more mature researchers and developers. We are missing the last mile that allow one to take a protocol and just run it without having all the burden of trying to build it from scratch and compile it and try to figure out all the parameters. So I'm sure Marcela had a lot of like time spending on trying to build and run those platforms, and I'm sure like you learned a lot from this process, and now you can do this easily for your own projects. But for someone who just begins learning about MPC, and like the math is difficult, so now understand how to understand the code that implements that math and then run it is even harder. It's not just a simple algorithm that I don't know, polynomial interpolation that it's kind of standalone. It combines a lot of building blocks that each one of them is complicated. So actually, this is something that I'm trying to tackle right now with a student, and we try to allow anyone to upload their MPC protocol. It should not be only MPC, but it could be also be a zero knowledge protocol or anything that requires like more than one party protocol, to upload it into what we call MPC Hub. And then from there, anyone could just click on that protocol and run it without even building it or compiling it. And we are quite in the beginning right now, and it's just me and another student. So we are looking for help on this. So if anyone is interested, feel free to reach me out.
MPC Hub, that sounds cool. Would it like throw you into a lobby, like you click on it and you end up running the MPC with other people who have clicked it on the time, like online checkers games?
Yes, exactly that. And I think like our goal is to help researchers right now more than developers. Because let's say I just build my MPC protocol. It doesn't matter for what purpose. It could be private safety resection or multi-server private information retrieval. And I want to compare it, just compare it with other protocols, right? I need to do that to put the results in the paper, right? Without that, I will have all my reviewers reviewer B. So I don't really want to go through all the hard work of compiling it and deploying it on AWS instances and so on. I would just go into this MPC hub and see what parameters I can plug into this protocol and just run. Of course, this has some costs, so we are trying to figure out who will pay those costs. I'm trying to help on this as part of VMware research, but I don't know like how it will be in the long run. For like, at least for now, it should be free, but there is still a lot of work to do in order to make it happen. So
Marcelo, just since Avishai called this part of it out, when you did your systemization, I think that in your GitHub repo, you first of all collected kind of like instructions for how to run all of the different MPC toolkits. That alone is valuable because they all had fairly, separate instructions. I think the standard is kind of like run a prototype in a local environment that, simulates multiple processes. It's not actually like 4 computers patch cabled together. Is that roughly correct? Do you think that there's any like a shift towards like deployment on clouds automatically or peer-to-peer or something else?
Yeah, so that you're correct that's what we did. The repo builds a Docker container that, like in most cases, just builds the thing automatically. I do have a couple pull requests right now to fix things, but yeah, and then you run all the parties locally on your machine. And I haven't spent any time trying to deploy this more generically, like for an arbitrary number of parties or on an arbitrary server of your choice. I think Avishai is right that it's a very hard problem. Like the user interface is bad. Like figuring out the like what the security parameters and security settings mean is very hard to do. It's not consistent across frameworks at all. I think that I know some researchers have done this independently for their papers. Like I think Marcel Keller probably did that when he did a massive performance evaluation of a bunch of frameworks, but I don't know if there's like a general purpose solution for that. I do think it's happening in private companies though. Like I think Microsoft Research is working on a platform to deploy their private set intersection resources automatically in Azure so that they're much easier to just like use easily. And I'm sure that like Facebook is probably trying to do something similar, but I have no inside knowledge there.
We're running low on time. I think rather than try to do a nice graceful exit, like closing remarks, let me ask one different question, and I think we'll just have to end kind of abruptly after that. And hopefully you all can maybe find a way on our Slack or the chat here to respond to other audience questions, because I saw a bunch somewhere low level. I really like this one question though, and we didn't prepare for this, so this will be spontaneous if anyone wants to respond to it. But do any of you have insights on like the role of incentives and crypto economics in MPC? Like I think attaching incentive mechanisms to everything is one of the really cool, novelties of the blockchain space. It's a really neat insight that you can use MPC to tackle the minor extractable value problem. Do you see other kind of areas of incentive design where MPC could solve the problem, or problems with incentives that MPC brings up? And I'll let whoever voices themselves first reply.
Yeah, I tried to touch it in one of the previous research that we've done, like just, for to have completeness. We wrote a section on it, worked on it with Itai Eyal, who is also IC3 director. And he kind of, it's super complex. At least for me at this point, like a lot of game theory. In our specific context, it was like we wanted to have a set of nodes to run MPC, and they would need to be incentivized to run the protocol, and then they need to. So we needed to introduce this kind of a judge functionality, and then like figure out how to implement it, and then how can we complain? How can you? It was a mess. So I have besides this anecdote, like I have no real experience to share about it, but I'm really curious about it. I believe that this would have huge potential, like to look into.
Marcelo or Avishai, want to react to the incentive issue as a last comment?
I also don't know that much about blockchain, the blockchain side incentives, but I know there was a paper that did it the other way recently, where it said like you put some money in escrow and then you run MPC, and then if you cheat while you're running MPC, the other parties can take the money that you put in. So that like it solves something in MPC where it's like, yeah, you shouldn't cheat because you'll lose something.
Sounds straightforward when you put it that way.
No, it solves fairness. No, it's true. It's true. I forgot about this line of work that like solves fairness using incentives and smart contracts. Yeah, it's true.
Hey, Avishai, last remark on that?
Yeah, I think they covered everything I had to say. So.
All right. Okay, I'll do the abrupt ending like I promised. Thank you for being on the panel, the three of you. I appreciate that so much. I hope this goes a long way towards jumpstarting and instigating the next generation of MPC researchers. So I appreciate your time and thoughtful insight so much. Glad you can make it.
Thank you so much.
Thanks for hosting.
Thank you.